Hi guys, welcome to the next lesson. In this lesson, we're going to be looking at strengths of acids and bases. So the learning outcome for today is to look at the difference between a strong and a weak acid and base, and the difference between the terms concentrated and dilute acids and bases, with common examples. So we already mentioned in the previous lesson, acids are substances that produce hydrogen ions or donate hydrogen ions, known as proton donors, in water. Whereas acids break up and they produce hydroxide, so therefore they're proton acceptors in water. Here are some examples of acids donating protons to form mostly hydrogen ions, whereas bases form mostly hydroxide ions in water. So acid and base strength is a measure of their ability to donate or accept protons. So a strong acid will readily donate its protons, whereas a strong base will readily accept protons in water. Conversely, a a weak acid won't be a very strong donator of protons, and a weak base, again, won't be a very strong acceptor of protons. So strong acids will donate their protons easily, readily. Strong bases will readily accept these protons, and weak acids won't donate their protons readily, and weak bases won't accept their protons readily. Here are some examples of strong acids and weak acids. You can see here is the acid molecule. We have the red part and the white part. The white part's the proton. This is the negative valence. This is the conjugate base. When the acid is put into water, it's mostly broken up into the hydrogen protons. Therefore, it is known as a strong acid. Whereas over here we have a weak acid, and that is most of the hydrogen ions are still remaining on the acid. Therefore, it is weak. So here are some more diagrams demonstrating strong and weak acids. We can see, and we already know, strong acids readily donate protons, like hydrochloric acid in water. So for example, here is a picture of hydrochloric acid. It is demonstrated by the forward reaction arrow in a chemical equation. So we can see, here's the acid, hydrochloric acid, it's added to water, and it will form its conjugate base, which is chloride, and the H plus protons, or hydronium ions. We see that the major species involved here, the major things that are in solution, are the hydronium ions, or hydrogen protons, and the conjugate base, the chlorine ions. Conversely, for a weak acid, they don't donate protons readily. An example is acetic acid or vinegar, and it will not completely ionize, will not completely form into its ions in solution. That's represented by this backwards and forwards reaction arrow. So here we have acetic acid, add it to water, some of it will form its conjugate base, which is the acetate ion, and here are our protons. You can see the major species involved is actually the weak acid. We have more weak acid than anything else in this solution. In both of these, water is not shown because the concentration is so large that it's difficult to see the actual other species. So water is the most numerous concentration, has the greatest concentration in both these solutions. However, we've omitted it just for purely seeing the differences between the hydrogen protons, the conjugate base, and the strong acid, and the weak acid, conjugate base, and the hydrogen protons. Similarly, for strong bases, they readily accept protons in water, such as hydroxide. So we look over here, here's our hydroxide, or our base, rather. It may be O2 minus, it may be barium hydroxide, a number of things. It's represented by a forward reaction arrow. It will readily accept protons and become the conjugate the conjugate acid there. Most of the species are our hydroxide ions, which will mean it is a base. Conversely, weak acids don't really accept protons, such as nitric acid here, shown by a forward reaction arrow and back reaction arrow. Here's our base. It's our major species in solution. Add it to water, and we have some of the conjugate acid here, and a few hydroxide ions, but mostly the original base. Again, you can see water would be the most numerous species here, but it's been omitted so we can see the differences between ions. So, if we put these two relationships together, you'll notice the stronger the acid, will mean the strength of its conjugate base will decrease. And similarly, the stronger the base, the weaker its conjugate acid will be. So for example, let's take hydrochloric acid, which is a strong acid. In water, it ionizes completely in water. 99.7% of the acid will form into the hydrogen protons and the chlorine ions. We take that, those two ions there, and we can see that the chlorine, the conjugate base, is actually a weak base. It will not readily accept protons. Similarly, we look at a strong base, such as hydroxide or hydrogen sulfide. It will readily accept protons in water, which means it's a strong base, but its conjugate acid is very weak. It won't donate protons readily. Now we're going to look at differentiation, or the difference between the term concentrated and dilute. So we've covered strong and weak acids and bases, and that's purely the ability to accept and donate protons. Concentrated and dilute is now what we're going to look at. So concentrated refers to the amount of solute in a given solution or solvent. So in this case here, we've got a weak acid, but it's concentrated. So weak acid meaning there's going to be mostly the original acid in the solution. However, it's quite concentrated, meaning there are a number of particles, a number of acid particles inside the solution. First, if we look over here, again, it's a weak acid because we have mostly the acid species. We don't have many protons. There's only one proton here. Conversely, there's 1, 2, 3 protons in here. They're both weak acids. They don't really break up into their protons, don't really ionize. However, this one's got a lot more, it's concentrated. This one's got a lot less, so it's dilute. A strong concentrated acid, such as hydrochloric, would look like this. We've got mostly the conjugate base and the protons being the major species in here, which tells us that the acid has readily ionized in solution. And there are a lot of the particles, there are a lot of the protons, and a lot of the conjugate bases. So therefore, it must be concentrated. With respect to this one here, where we have complete ionization of the acid over here, this acid has completely ionized to form protons in the conjugate base. However, there are not many of them, so we define it as dilute. So concentrated but weak, concentrated but strong, weak, dilute, and strong, dilute. So the summary of today's lesson: the stronger the acid, the weaker its conjugate base will be, and a strong acid will readily donate protons, whereas a strong base will readily accept protons in water, and weak acids won't readily donate protons, and weak bases won't readily accept them. A concentrated and dilute acid and base means that the number of moles or the number of particles you have in the solution will change. So you should be able to identify strong and weak acids and bases, what the difference between a concentrated and dilute acid and base is, and explain the difference between strong and weak acids and bases. These are the questions to complete. Thanks for watching.